Welcome to the LeanTech robot training videos. This video will illustrate on how to navigate the LeanTech robot controller. At the end of this tutorial video, we hope our precious users will be able to navigate our robot controller hassle-free. For your information, this video also contains a brief explanation regarding what functions and applications are currently available on our robot arm. So, let's get started. This is our friendly software screen display. The top bar is the status column. Besides the time and status in the far left side, other displayed information are pushable button. Here is the content. The content consists of 10 shortcut keys, which displays the main functions offered by our software. This content is visible at the home page. The menu bar, which consists of different tabs of functions, can be found at the bottom of the display. This bar will be visible at every page, but varies based on the current page viewed by the user. The tabs at the top of the screen are displayed as accordingly. System mode can be divided into two types: manual and auto. The difference in operations between auto and manual mode will be explained further in the next video. When the mode button is pressed, the state of the current operation can be switched between manual and auto. Pressing the user tab enables us to choose between the world coordinate or the user coordinate. User coordinate can only be switched when it's in manual mode. Tool coordinate tab also offers two options. The user can choose the coordinate system assigned either on the flange or on the tool. This function is only available for 6-joint robot arm. The override mode basically controls the speed of the movement and motion of the robot arm. At manual mode, the interface is displayed so. The range of the override offered is between 10% and 100%, with the latter means the robot arm is moving with the highest assigned speed. Or alternatively, user may choose the preset incremental value and override percentage available. During auto mode, the button of the incremental movement or InJog will be deactivated. Here located the alarm to notify the user about the error or failures of the running program. For safety reason, the program will be brought to stop and the light will start blinking red. Clicking on the operation panel will summon the movement control panel. The interface of the operation panel is displayed as following when at manual mode. At auto mode, the display will pop up so. As can be seen, buttons for the rotary and translatory movements have been replaced with a more comprehensive panel. The button for accessing the authority is located at the top right of the screen. Clicking on it will open 4 different tabs which indicate the level of authority to running the robot controller. Each alphabet which indicates different level of administrators will gain different types of authority based on the granted permission. As stated before, the content consists of main functions that are essential in controlling the robot arm. Peripheral control setting can let operator operate peripheral object in real time. It is divided into 2, PLCM code and subprogram. Commands are then assigned under actions. Each command can be executed when clicking on it. User can also edit the name. Besides, user can navigate through multiple pages by clicking the arrow button. Status monitor page can let operator observe real-time status of current robot arm. Current procedure will display program that is currently executing. Besides, the screen also displays the current arm position, arm velocity and the status of each arm. Under User Coordinate, our users can self-define their coordinate system. Under Process, our user can select the method to set up the teaching points. It can be done by manually modifying the intended coordinate or keying in the origin and other 2 points on XY plane. Tool coordinate system is Cartesian coordinate system that is located at the center point of the tool connected to the end of the robot arm. The teach process consists of 4 available options: 3-point teach, 4-point teach, 6-point teach, and manual input. This will be explained further in our next video. Input-output monitor is used not just to indicate which I/O system or device is currently running. Under Output tab, output devices or systems can be switched on and off by simply clicking on it. For the robot arm to execute the movement repeatedly, reference points need to be taught and then saved. The file name containing the reference points can be found here. These two tables of coordinates compare the current position and the desired teaching point coordinate. On the right side is the list of each reference points that have been saved. Further explanation of its operation can be found in our other video. The import-export function is used to transfer system data, macro and customized string. These two buttons are basically for system data backup and restoration. By clicking on this icon, it will display more information about the hardware and software of our robot arm. At the home page, the menu bar consists of Program, Functions, Applications, Settings and Systems. To program the movement order, simply click on Program. Make sure the system is in manual mode to edit or summon a program. Here you can find the Program Edit command. The commands include types of motion, control, logical statement and etc. This chapter will be covered further in another video. Additionally, the menu bar on the current page provides shortcuts to the main content. Thus, our user could access such functions without having to return to the home page. By clicking the Functions tab, it'll turn to a new page displaying the user, tool coordinate, offset content, and to work home content. Besides, our current software is equipped with presets application packages, such as pick and place on a pallet, tracking on a conveyor belt and arc welding. After choosing the desired application, inserting the parameters is now much easier and faster due to our more user-friendly interface. Under System, our user can gain a fast diagnostic status of the input-output devices of the system, as well as maintenance issue regarding the operation error. As shown on the screen, clicking on the tab of Alarm History will display the series of past warnings and errors. In conclusion, our user interface makes it easier for the high-end users to navigate the robot controller. As it might be seen, certain functions are only accessible by an individual with higher authority. Lastly, do check out our other videos for further explanations. Thank you.